So what we need to make the sine law work is we need to have an angle and opposite side pairing. So this is really important. Okay, so this is where you can see whether we are able to apply the sine law. If we have an angle and opposite side pairing, that means we can apply sine law to a problem like this. Okay, because we can convert this into a sine ratio and then make a ratio with the length of the opposite side. So that's a key point. So I'm going to maybe make a point here. So make sure you have an angle and opposite side pair. Okay, so this is very important criteria for being able to use the sine law. Okay, so in this case we do. So we're going to set up the sine law. Okay, so when we set up the sine law, it looks like this. We take the angle, okay, and the opposite side. So I'm going to put, doesn't matter which way you write the ratio. I'm going to write the side and the side on top, sine on bottom. And this way, as long as we make sure that the other pair has the same orientation, so sine on bottom, so 35 degrees. Okay, so that's my sine. And then I'm going to call this side B. Okay, we're going to call that side B. And then we can solve for side B because we have a angle opposite side pair. So here's one pair. Okay, and I'm just going to highlight the other pair here. This is the other pair. Okay, as long as we can make that ratio, equivalent ratio, and only have one part to solve for, in this case we have this ratio pair that we can pair together, that's known. That way we can compare any other side and angle pairing to this known pair here. So solving for this, I'm just going to rearrange this first. So I'm going to end up with sine of 35 degrees over sine of 60 degrees times 25 is equal to B. And again, the reason why we have to use sine 60, we can't use 60 because 60-degree measurement is just kind of some random measurement that has nothing to do with length. When we do sine 60 is a ratio. Now we're talking about length measurements, and that's why we have to use a sine 60 to be able to do some math with this number and this number. Okay, otherwise there's no math that can be done between 60 degrees and a measurement unless we convert it into some kind of length ratio. So here we're going to do sine 35 divided by sine 60 and times by 25, and we get the length of B. So we get 16.56. So length of side B is equal to 16.56. Just going to write it in there, 16.56. Okay, so we've got two sides, two angles. We need to get the third angle and third side. Well, in this case here, since we know two angles of the triangle, we can find the third side by subtracting from 180 degrees. So it's going to be 180 minus 60 is 120 minus 35 is going to give us 85 degrees. Okay, we'll call this side C, and then we can solve for side C by doing the same thing. So I'm going to use my known ratio of 25 over sine 60. Okay, and that's going to be equal to side C over sine of 85 degrees. Okay, so again, we use our given angle side pairing to solve for some unknown angle side pairing. Okay, so this ends up being sine of 85 degrees over sine of 60 times 25 as a factor, and that's equal to length of C. That works out to be, okay, so what do we get here? We get 28.76. So C is equal to 28.76. Okay, so there's our triangle that's solved. Okay, we've got all three angles and sides. Okay, so that is, we've now solved that triangle. Okay, so here's